Hi! In this video, I'll show a method of using a known valid siteswap to find another corresponding valid siteswap. I found this method from the graph paper diagramming method, and the diagrams make it easy to see why it works. I'll just be covering asynchronous siteswaps where no more than one ball is in a hand at a time. From the method, we'll be able to tell an interesting fact about these basic siteswaps. If we let P represent the period of the siteswaps, and we let B and C represent two numbers of balls, each greater than 0, then we'll be able to tell that for any period P, the number of B ball siteswaps up to height B plus C is equal to the number of C ball siteswaps up to height B plus C. For example, the number of 3 ball siteswaps with a period of 5 and throws up to height 7 is equal to the number of 4 ball siteswaps with a period of 5 and throws up to height 7. Here I have the frame, with the horizontal lines labeled as throw heights from 0 to a maximum height of 7, and the vertical lines labeled as beats 0 through 4 for a period 5 siteswap. I'll add some throws as diagonal lines 45 degrees down and to the right, continuing all the way to height 0. I'll start by adding a 3 to beat 3. Now I'll add a 4 to beat 2. We see that the line reaches the throw from beat 3. Overlapping lines won't be allowed in these siteswaps, because that would mean a beat has more than one catch, so more than one ball would be in a hand at a time. So instead of adding another ball, that throw is replaced, and now there's no throw on beat 3. Since we're drawing the diagram this way, we can assume that there's no beat with more than one catch. Now I'll decide I want to keep the 4 on beat 2, so I want to know which throws can't be added in order to not replace it. I'll draw a dotted line up and to the left until it reaches the maximum height, and then I'll know that I can't add a throw on the dotted line. Now I'll add a 7 to beat 0. Since 7 is the maximum height, I won't have to draw a dotted line to ensure that I don't replace it. Before I continue adding throws, I'll review what makes a siteswap valid. Siteswaps have the rule that if a ball is caught on a beat, that ball is thrown on the same beat. From this rule, 3 other rules can be deduced. If a ball is thrown on a beat, then a ball needs to be caught on that beat. Otherwise, there would be no ball to throw, because any ball that had been caught before that beat would have already been thrown because of the first rule. If no ball is caught on a beat, then no ball is thrown on that beat, because that would mean that no ball is in the hand to be thrown unless it was caught and not thrown on a previous beat, which would break the first rule. Finally, if no ball is thrown on a beat, then no ball is caught on that beat, because catching a ball on a beat and not throwing it on that beat would break the first rule. Here we see that beat 0 has no catch, but it has a throw. I'll make sure beat 0 has a catch by adding a throw backwards from height 0 at beat 0. I'll stop at beat 4 and get a height 1 throw. I'll decide to keep this height 1 throw and draw another dotted line. Now beat 4 has a throw but no catch. I'll add a catch to beat 4 by going backwards from height 0. Say I stop at beat 2, which already has a throw. Since the diagram isn't allowing more than one catch on any beat, we can tell that the two throws from the same beat will mean that there's a catch without a throw. This is because each line representing a throw has a throw end and a catch end, so the total number of throws is equal to the total number of catches. Having two throws on a beat will mean there will be more beats with catches than beats with throws. Here we see that 3 beats have throws, and 4 beats have catches. Beat 0 has a catch and a throw. Beat 4 has a catch and a throw. Beat 3 has no catch and no throw. And beat 2 has a catch and 2 throws. Beat 1 is the beat with a catch but no throw. To find out if we have a valid siteswap, we won't need to check for beats with more than one throw, and we won't need to check for beats with more than one catch. We'll just need to check each beat to make sure that it doesn't have a catch without a throw or a throw without a catch. We can even simplify this further and just check that no beat has a catch without a throw. This is because if we know there's no more than one catch on a beat, then if there's a beat with a throw but no catch, then the remaining number of beats with throws will be one less than the remaining number of beats with catches, so one of those beats will have a catch but no throw. This can be helpful as an easy way to verify that a siteswap is valid. If we're trying to generate a siteswap from nothing, it will still help to check for any throws without catches or multiple throws on a beat, because this will let us know what needs to be done to get a valid siteswap. I'll extend the line landing on beat 4 back one more beat to beat 1. This fixes the problem of having multiple throws on beat 2 and adds a throw to beat 1. I'll decide to keep this throw and add a dotted line. I'll also decide I don't want the ball to land on beat 3 and draw a dotted line from height 0 all the way to height 7. We can see that now beat 0 has a catch and a throw, beat 1 has a catch and a throw, beat 2 has a catch and a throw, beat 3 has no catch and no throw, and beat 4 has a catch and a throw. So this is a valid siteswap. We have a 7, 3, 4, 0, 1. Now, without changing any of the diagonal lines, I'll get a new valid siteswap. First, I'll turn the paper around so that the diagram is upside down. Now I'll add new labels for heights 0 through 7. I'll relabel the beats, so each beat will become the period minus 1 minus the number of the original beat, or 4 minus the original beat. Beat 0 becomes 4 minus 0, or 4. Beat 4 becomes 4 minus 4, or 0. Beat 3 becomes 4 minus 3, or 1. Beat 2 becomes 4 minus 2, or 2. beat 1 becomes 4 minus 1, or 3. And the next beat 0 becomes 4 minus 0, or 4. Now I'll label which hand throws on which beat. Now, the dotted lines will represent throws instead of the solid lines, and the solid lines will represent the emptiness that had been marked out by the dotted lines before. Since we started with a valid siteswap, there was no beat with a throw but no catch, and no beat with a catch but no throw. This leaves us with 3 possibilities for beats. One is a beat with a catch and a throw of the maximum height, or 7 in this case. Since there was a throw, there was also a catch, so a solid line reached the bottom, which means a solid line now reaches the top. The solid line started at the maximum height, so now it reaches the bottom, or height 0. So now the beat has no throw and no catch. The new beat 4 is an example of this. Another possibility is that a beat had no throw and no catch. Since it had no catch, a dotted line reached the bottom, which is now the top, so a dotted line now starts at the maximum height, so it has a throw of the maximum height. Since it had no throw, the top line had to have a dotted line reaching it, otherwise it would have been a throw of the maximum height. So it also has a catch. The new beat 1 is an example of this. The only possibility left is where there's a catch and a throw of any height other than the maximum height. Since there's a throw, a solid line started and a dotted line finished on one and only one of the throw heights. No other dotted line can now start on that beat, because if it did, then that would mean more than one ball had been thrown on that beat in the original siteswap, so there's still one throw. Since that throw wasn't the maximum height in the original siteswap, a dotted line had to reach the maximum throw height, so now a dotted line reaches 0, meaning there's a catch. So there's still a throw and a catch. The new beats 0, 2, and 3 are examples of these. Since none of these possibilities lead to a catch without a throw or a throw without a catch, if we start with a valid siteswap, we'll have a valid siteswap after turning the diagram around. Starting the siteswap at beat 0, we get a 6, 7, 3, 4, 0. I'll refer to this function generally as a height inversion, or more specifically, the height m inversion, where m is the maximum height. Since the maximum height in this case is 7, I'll call this the height 7 inversion of the 73401. I'll turn the diagram back around now. Since nothing in the diagram has changed, we return to the 3-ball siteswap that we started with. Now I'll add a 5 to beat 3. We get a 7, 3, 4, 5, 1, which is a 4-ball siteswap. The diagram helps to see why adding the 5 works, but if we want, we can do this numerically by adding the 5 to the previous throw height. The same would be the case if we were to subtract 5, or if we were to add 1 to each beat or subtract 1 from each beat. I'll turn the diagram upside down to see what the height 7 inversion is. It's a 3-ball 6, 2, 3, 4, 0. I'll turn the diagram back around to get back to the 73451. Now I'll swap beats 1 and 4. When I do this, I bring the height of beat 4 up once for each beat back until it reaches beat 1. This means if I wanted to just change the number to get the new site swap instead of changing the diagram, I would have to add the difference between the beats being swapped to the height of the later beat and make that number the height of the first beat. Since there are 3 beats between beats 1 and 4, and beat 4 was a height 1, now beat 1 is 1 plus 3, or 4. I also bring the height of the previous throw from beat 1 down once for each beat forward until it reaches 4. This means I would also have to subtract the difference between the beats from the earlier beat and make that number the new height of the later beat. Since beat 1 was a height 3, when we subtract the difference between the beats, we get 3 minus 3, or height 0, for beat 4. The other beats aren't affected, so we can just copy them over. So here we get numerically the 74450, or by the diagram, 74450. Now I'll explain how we can get the height m inversion numerically. I'll turn the diagram upside down. Going by the dotted lines as throws, we have the 7, 2, 3, 3, 0. When we turn the diagram around, we can see that the order of the beats gets reversed. We can also see that if a throw moves toward the now upside down maximum height, or 7 here, it will go the number of beats between its current height and the old height 7, so numerically, we need to find the difference between the maximum height and the old throw height for the new height of each beat. So the new value for each beat will be 7 minus the old throw height, and the order will be reversed. For example, the old beat 3, which is now beat 1, had been a 5, and now it only has to go 2 to get to the old height 7, or the new height 0. So now beat 1 is a height 2. To find the height 7 inversion of the 72330, we would subtract 0 from 7 and get 7, 3 from 7 and get 4, 3 from 7 and get 4, 2 from 7 and get 5, and 7 from 7 and get 0. And this is what we had before we turned the diagram upside down. I'll turn the diagram around again. Since the average of the throw heights of the original Siteswap is the number of balls in that Siteswap, the average of the throw heights we get after subtracting each height from the maximum height will be the maximum throw height minus the number of balls. This means the number of balls in the new Siteswap will be the maximum throw height minus the number of balls in the original Siteswap. So if we have two numbers of balls b and c, then the height b plus c inversion of a b-ball Siteswap will give a c-ball Siteswap, and the height b plus c inversion of a c-ball Siteswap will give a b-ball Siteswap. If b is equal to c, then the maximum height b plus c is equal to 2 times the number of balls, and this gives a Siteswap with the same number of balls. The number of b-ball Siteswaps of any period and height is equal to itself. For cases where b does not equal c, we can turn any b-ball Siteswap diagram around to get the corresponding c-ball Siteswap, and then turn the diagram back around to get that c-ball Siteswap's corresponding b-ball Siteswap. Likewise, we can turn any c-ball Siteswap diagram around to get the corresponding b-ball Siteswap, and then turn the diagram back around to get that b-ball Siteswap's corresponding c-ball Siteswap. This means that the b and c-ball Siteswaps up to height b plus c exist in pairs. Therefore, for any period p, the number of b-ball Siteswaps up to height b plus c is equal to the number of c-ball Siteswaps up to height b plus c. Now, for a few examples where b equals c, I'll show two common period 3 4-ball Siteswaps and their height 8 inversions. I'll just use the numerical function for these. I'll start with the 552. When we subtract 2 from 8, we get 6. When we subtract 5 from 8, we get 3. And when we subtract 5 from 8, we get 3. So we get the 6, 3, 3. This is a different Siteswap than we started with. Now I'll try another one. I'll start with the 534. Eight minus 4 is 4, 8 minus 3 is 5, and 8 minus 5 is 3. So we get the 4, 5, 3. Now, starting with beat 1, we get the 5, 3, 4, which is the same as the 5, 3, 4 that we started with. So we see that when the maximum height is 2 times the number of balls, the height inversion gives a Siteswap with the same number of balls, which may or may not be a different Siteswap. This concludes this video. I hope it's been helpful and interesting.